So I do not see any queries regarding this, the 20 lectures that that you have gone through. And wait for your for query if at all. But what I want to say is that I think you have gone through 20 lectures. I've tried to keep it a easy way of describing lasers to you. And it would have been good for if you had given the query, then it becomes easier for me also to understand where there is a bottleneck or where somebody is unable to answer certain questions. And even if you don't ask the questions here, again, the forum is always open to you to ask the questions, and it will be answered, definitely will be answered. So as I can see, in these 20 lectures, not only was it what should I say, introduction to lasers, but I think you would have got enthused to even take up lasers as your career prospect subject. In any case, so what I have covered in these 20 lectures, let me just summarize to you and tell you what exactly you need to understand in lasers. Okay. First of all, it is the basic process, the basic theory, which you should understand. And secondly, an actual way of operating a laser. Even if, say, somebody else has made it for you, you should be able to operate the laser. And for even that sort of operation, you need to know some basics of lasers itself. Because it is a specialized instrument, very specialized instrument, which not anybody can operate, and find its problems. It's not become a touch screen or touch the instrument and it starts working. It's not exactly that. So here we have a very coherent source of light. That's what I have discussed, the coherent source. It is very important. It's a very important property of any lasers. And I should say another property of lasers, which is very apparent, is the intensity, which is the intensity. That you can understand very easily, what is the intensity. But understanding coherence is, it's a bit of an abstract concept. which also I have described in the last 20 lectures. And then I have put a lot of emphasis on non-linear optics. Okay, that may be new to you in many ways. People have heard about linear optics, which you see in, say, everyday life. You have ray optics, a ray of light passes through a medium and it comes out in a certain way. But in nonlinear optics, you have generation of new frequencies, new light, new wavelengths. Okay. So that is what I have tried to emphasize on. I think uh, if you repeatedly go through those lectures, you will definitely have a uh, basic idea. So what is keeping you from asking a question? I think one should not be shy, and one should not hesitate to ask a stupid question, because nothing is stupid until you know the answer. Until you know the answer, it may seem stupid, but then once you know the answer, you are the you have you know the answer to something that many other people don't know. So I would encourage you to ask uh, stupid questions also. So as we go ahead, you will see the other lectures which are coming through. But these first 20 lectures puts a trend to the kind of subject that you're tackling with. Okay. So go ahead and ask. In fact, I would like to know uh, what kind of, what did you think about the Einstein's coefficients? Einstein's coefficients for absorption and emission. Okay. Because that is a very, very important coefficient that is required, to know the basics of lasers. And then one more thing, uh, I think you have still gone through the within those lectures the types of lasers. I've discussed carbon dioxide laser. I've discussed ND glass laser, and many of them are used in many laboratories and they are commercialized. So the subject of laser has reached such a point where they have been commercialized. Okay, here I can see one question. Uh, Do you have any tips for best utilizing the course material? Uh, it depends on for what you want to use it. Utilizing in the sense, see, practical material, if you say, if you don't have a laboratory to work with, then it may be a bit difficult. But then, you can try out different things with even laser pointers. Laser pointers, it is a tiny thing. You can just buy it in any shop. It comes with a red light, green light, blue light. You can try out many things with that. In fact, you can try out with this laser pointer how to measure the distance between the chair you're sitting on and the wall. Okay. So you see how it goes there and comes back. It's like a small experiment. Otherwise, the pointers are always, that is the sort of a laser which you can come across in a everyday kind of a life. Otherwise, the big lasers, you need a laboratory. I don't know if you are part of any laboratory for, I don't know, are you a part of any laboratory? Some institute where you have access to a laser laboratory. It may not be a laser laboratory, it can be a spectroscopy laboratory, it can be a solid state physics laboratory. It's basically used in all laboratories. Okay. So tips for best utilizing the course just depends on you, how you want to utilize it. You go through the exam, you go through all that. I'm sure that has a lot of value. Okay. And you have increased your knowledge in this field. I don't know. I hope this answers your question. Well, yeah, you are applying for masters abroad next term. I am doing to get some idea of what is Q hat, Q question, QHAT. I am getting into. Yeah, okay. You're getting into a master's abroad. Yes, this as a background will really help you. I don't know if there are some, I'm sure they will be asking you certain questions, and this course will also help you to answer some of those questions if that is the case. But this much I can tell you, you are applying for masters abroad in a foreign country, especially America or in Europe. Yeah, they definitely use lasers as an everyday tool. And I think if you get into one of those labs, you'll be able to handle the lasers very well. That much I can guarantee you. What? Acha, get some idea of what I am getting into. Uh, what I am getting into. I'm sure you're getting into something good. I mean, don't be afraid to do a master's abroad. And if you are interested in optics, then laser is something like a background subject you always need. Okay. You will need it. No laboratory. And if you're doing masters, and I'm sure you would like to do a PhD after that, even if you don't do a PhD, even in masters itself, your many laboratories there have lasers in them. And if you choose some optical subject which is optical in nature, optics, there are plain optics also. It may not include lasers. It can be Raman scattering or some spectroscopy. All of them will need a knowledge of this laser course. Even suppose your master's is in spectroscopy, they will give you one course on lasers, because no spectroscopy is done nowadays without lasers. Yes, if you are aiming for a master's in optics and photonics, then you have chosen the right course. You've definitely chosen the right course. And go through it with a lot of interest. Yes, and especially photonics. Okay. So everything is in terms of photonics. That means, they use semiconductor lasers. Those kind of things are used in photonics. Photonics is nothing different from usual photons, but in a smaller scale it is used. Transmission of light, through optical fibers, and losses and no losses there. So I think it has a lot of scope for you later on, but it is photonics, especially optics and photonics, is a ongoing subject. So don't worry too much about whether this specific course will be useful for me in masters or not. In masters, you have to do quite a few other courses, including photonics and optics and photonics. Okay, it's not an individual thing. But then this will, since you have so much interest in it, I'm sure it will give you you will be ahead of your classmates, I should say. Oh, yes. Okay, so Arman Ahmad, I think you've done a good thing. You've taken it as a prerequisite, and it will definitely help you. Even if it's a project in nanophotonics, it will definitely help you. I give you a thumbs up for choosing nanophotonics as your subject. Okay. You should be able to tell me whether these 20 lectures that you have gone through, uh, has it helped your understanding, say, towards nanophotonics? Has it helped you? In my opinion, it should have. Because at some time or the other, maybe you haven't gone into the depth of nanophotonics, but this courses, you have some idea of what nanophotonics is about. Okay, it's not very much different from just photonics. Nano is just a name they've put that because you're using it in this nanoscale and nanoscale techniques. But the laws of optics, nonlinear optics, remain the same, whether it is for photonics or nanophotonics. Where, may I ask you, uh, Arman Ahmad, where may I ask you, you would like to pursue a project in nanophotonics? Or is this the first time that, since you're in semester 1 of MSc, uh, is this the first time that you are coming across a course in lasers? Or have you learned some part of it even in your BSc? Whatever lectures you have seen till now, have those been covered in your BSc level or somewhere else? Oh, okay. Since you're getting a better understanding, I'm happy to know that. I'm happy to know that I have been able to convey something that you appreciate. Yeah. Yeah, I've tried to keep the lectures so that see, you cannot do physics without or optics without absolutely any equation or any mathematics. That can never happen. Okay. But I have tried to give the physical interpretation of all the mathematics that has been used or all the equations that have been used. Okay, so you have learned something in optics and electronics course you have done. Actually, if I were to tell you, yes, optics and electronics course, and you must be able to relate to those courses when you go through this particular course on lasers, because on an average, lasers by itself, when you go through it, it's an amalgamation of many subjects put together. That is why this course is not introduced at a very basic in the first year BSc or say in 12th standard. Okay, it is not introduced there because it is
the house. हाँ भैया वो बिल्कुल हाँ कंटिन्यू
हाँ इसमें ही करूँ।
हाँ हाँ
ये देखो कुछ
मैम
मूव नहीं हो
वो
रहा है।
डिले है थोड़ा मैम आपको उसमें कुछ और मत करिए
इसमें करो। ये देखो कुछ होगा।
यहाँ क्वेश्चन देखिए हम।
हाँ हाँ देखती हूँ. I was able to understand Einstein's equation and other topics as we had touched upon it in the EDC subject in BTech, ECE. So far, so good. Okay, I think, sorry to say that we just got cut off like this because there was electricity shut down at this studio. And but then what you can do is you can, if you are still connected, I think we'll stop here and you can always put in your queries, whatever the queries may be, on the common forum, and I will surely answer them as far as I can to help you out. And here you have written that I was able to understand Einstein's equation and other topics as we had touched upon it in EDC subject in BTech. Okay, that's fine. That is good to know. And then one more, Arman Ahmed has written, ma'am, it's the first time until now we've had covered some of these topics in optics and electronics course. Good to know, good to know. I think go ahead and do put in your queries very freely. Okay, you will definitely benefit through it. And everybody is looking at it, and anybody can give any sort of answer. Everything is welcome. It is a learning process. Okay. Thank you then for this interactive session. And I think there will be one or two more after a few more lectures are over. Okay. I hope you will be more enthused to come out with your queries then. Okay. Okay. Bye.